page gets sent to the client, it figures out I already have a copy of this picture. So it doesn't have to load it. And it will continue to do that for everything else that it has copies of. This makes it a lot faster to show the web page. And that's why we use web cache. We download files once, and then if we don't need to, we don't download them again. Unfortunately, you can time how long it took to load a page, or even just an image in a page, and figure out whether or not somebody has loaded it already. For example, here on the left we have a real server, and on the right we have a phisher. He's denoted by the devil. And the client in the middle is going to be a victim of one of these cache recon attacks. First of all, it's going to go to the phishing web page, and the phishing web page is going to say, load these 3 images. First, it loads an image off the phisher's website. Second, it's told to load an image from this other website. Maybe it's a bank. And then third, it loads another picture from the phisher's website. Now, when it's done in this order, the phisher can approximate how much time between picture 1 and picture 2 has elapsed. And when that's done, they can approximate how long it took to load the middle picture. Since if the picture was already on the computer, it practically takes no load time. That can be compared to how long it would normally take over a network. And so using some statistical methods, you could figure out whether or not the picture was in the person's cache. If the picture is a logout button, that means the person has logged into a website. If it's a logout button at a bank's website, you know the person has an account with the bank. So this is a problem. Unfortunately, it's not easy to implement, but there's also the browser history that you can look at. So let's explore that a little bit. This is a normal web page with 3 links on it. It's relatively straightforward. It uses cascading style sheets, which is the stuff between the style, this style, and the slash style. Cascading style sheets are simply there to make text and images and layers on web pages look different. It's not a programming language. It's just a styling sheet. The red here, the colon visited, says that if I have a link with ID number 1 and your browser's been there, make it red. You've all seen this. Browsers normally have blue links that are underlined, and if you've been there, maybe they're purple. This is very common. Well, this in itself isn't a problem, and as you can see, I visited link number 2. It's red. Or instead of changing the color, you can change other attributes of the links, like the background. Okay, so what does this have to do with detecting the person's history? Well, if you can change the background, you can tell it to set the background to a URL, a different web address, maybe the phisher's web address. So now this web page is phoning home for every single link that's been visited by your browser. Not only do I know that you've visited a web page, but since each link is colored with a different ID, I can figure out which links you've visited. And of course, you can make it invisible. So this is a particularly nasty attack. And I don't really want to talk more about how the attack works, since there's all sorts of literature all over, and it has nothing to do with the research we did, except providing the basis. So I'm going to go right into why this is a problem and how to solve it. You can get links that people have visited. When they come to your web page, you can use this technique, find out where they've been. But how do you find out who they are? You send them a phishing email. The phishing email has a link in it that's custom to that one email address. This is normally done by phishers to figure out which emails worked, or spammers to figure out which emails worked. And then when they come to your website, they bring the email address with them as part of the link. The phisher then sends a web page with lots of links on it to test where they've been. And some hits are sent back to the phisher's website saying, I've been here and I've been here. And now they know who has been where. And they can begin phishing. Additionally, instead of requiring the initial phishing email to bring them to the site, you could also try and exploit the autofill feature of many browsers and automatically extract the email address from the person's browser as well. And this combination is particularly nasty. And of course, there's something called a chameleon attack that's really bad. This combines a web page that sniffs where you've been with a web page that looks different depending on where you've been. You get the page, and then it phishes you. It finds out what your history is, and then depending on which bank you probably visited, it looks different. In principle, this could be done in emails as well. So one email could be sent out to a ton of people, and it looks different depending on who looks at it. So far, the only vulnerable clients that I've been able to confirm, as far as this email chameleon attack, are web-based email clients. So that's a good thing. So anyway, moving on, there are solutions to this. At the World Wide Web Conference in 2006, some people from Stanford presented a client-side fix, a browser plugin that essentially isolates your history. So each domain that you visit is allowed to see history items from that domain, but nowhere else. According to bank.com, you've been nowhere outside of bank.com. It's a good solution, but people have to install it. How many people are going to actually install it? How many people are going to turn it on? It has side effects. If you have a web page with a bunch of bookmark links on it, they'll never turn purple. You don't know which ones you've been to. So it's not perfect, and none of the solutions are. You could also change the standards. That's what I mean by CSS limiting. Changing standards is not easy, so we won't do it. You can convince people to be paranoid. Clear your history every time you visit a web page. People aren't going to do it. They like their history. I like to go back. I don't know about you. I like my back button. And of course, you could attack it from the other side. You could say, well, I own a banking website. I want to make all my customers safe, so nobody knows they bank with me. And that's what we're going to do. So there are two goals that we have in implementing a solution on the server. We have to make it hard to guess any URL that I've served. Any picture, any web page, any style sheet, any flash animation. I want to make it hard to predict what the actual URL was when the person loaded it. Additionally, I want search engines to be able to index my website with predictable names. If I own bank.com, I don't want them to come, I don't want people to go to the search engine and type in, where is bank? And come up with garbage-looking URLs. They won't trust those, and the search engine won't like that. So those are the two important things. So somewhat formally, this is what it looks like. I'm chase.com, an example of a banking website. I serve pages to clients. Those clients, when they load the page, enter that into their history. I don't want a phisher to be able to predict X, which is entered into their history. Additionally, if you throw a proxy server in the mix, it gets a little messier. But I don't want to be able to predict X, which is in the client's history, or the proxy server's history. This is important. So I'm going to use two techniques to present the solution. There are two things that it's going to do on the server side. First of all, it's going to add pseudonyms to all the URLs that it can. These are randomly generated numbers. They're long strings. And if Fisher was trying to enumerate the number of possible pseudonyms on the end of a URL, they'd run out of time quite easily. These don't take very long to generate, so that's convenient. Additionally, there are some URLs you can't put the pseudonyms upon. It's just that hard. So we're going to do something called pollution. So this is pretty straightforward. If I go to bank.com, it automatically sends me to a whole bunch of other links. Bank2.com, bank3.com, google.com, ebay.com. All of those get entered into my history, even though I didn't specifically go there. This is really convenient. If all the banks collude, they can all enter all the banks' names into my history. Now, all they know, if you're a phisher, all you know is that I've gone to a bank's website. You don't know which one. But that can be kind of mean. Generating a bunch of traffic that's unsolicited is not a good idea. So we don't want to use that unless we absolutely have to use that. So this is what web browsing looks like right now. A web page is requested, and it's sent. We've got the server on the right and a client requesting the page on the left. After our solution, this is what it looks like. They request with a pseudonym. This is the pseudonym on the left.